So today we'll be discussing about error detection mechanism. So what is an error actually? When you are sending a data from source to destination, there are disturbances both in internal devices as well as in external because it has to go, the packet has to be routed towards different networks, and when it reaches the destination point, so there are a lot of disturbances in and around the external devices. So that kind of problem we will call it as an error. So to detect an error, there are two types of error is there. One is single bit error, another one is called as bursting error. So single bit error is that if you are sending a data, if there is only one bit has been changed, either 0 to 1 or 1 to 0, we will call it as a single bit error. A burst error is something like if you have more than one bit, there is a change in more than one bit, we will call it as burst errors. So this is what you can see this here. There is a change in 0 to 1 here in the receiving end. All this data has been delivered from the source end that has been sent, but at the receiving end, there is one more bit has been changed from 0 to 1. So this is, we call it as an error control. That is an error detection mechanism. And this slide is called as a burst error. You can see more than one bit has been changed. 0 is changed to 1, 0 is changed to 1. So you can see so many places that the bit has been changed. So this is called as a burst error. So we need to identify in the receiving end whether the same packet has been received or not. If I am sending a message, if I'm converting this message into sequence of bit streams, the same sequence of bit stream has to be delivered to the destination end. So for this, I can use a different mechanism. The first mechanism is called as cyclic redundancy check. This is the most popularly used error detection mechanism to check whether any bit has been changed in the receiving side. One more mechanism is called as checksum. So today we are going to discuss about this cyclic redundancy check. This is one of the error detection mechanisms. Clear up to this? Myself is audible or anything you want to convey?
No, sir.
No. Okay, fine. Now, see, the first thing is that when you go for CRC mechanism, there is a concept called redundancy. What is called redundancy? Redundancy is that an information will be sent, the same type of information will be sent. Say for example, I think you might have seen in a few websites like if you're typing a username and password, it will ask for you to retype for one more time password, confirm password. So what actually it is, why it is asking for retype password in the sense already you have typed a password, again you are asking for the second time to enter the password. So when you are sending a data two times at the receiving side, suppose if a data has been dropped somewhere, that the packet has been dropped, you have a chance of receiving the same data again. Am I correct? I'm sending a message. Suppose the message has been discarded somewhere in the network. Suppose if I'm sending two times the same message, first time the message has been discarded, you can able to receive the second message so that you could able to recover back the original message. Am I correct? But what is the drawback of this message? What is the drawback of this method? Suppose if I want to send 1,000 messages, I need to transfer 1,000 into two times. So 2,000 messages has to be transmitted, which takes a lot of times, right? So this method becomes very slow. So before going for CRC, this was the technique that was been adapted. While you want to send a message, duplicate the message, and the redundant message will also be sent along with the original information. The drawback is that complexity gets increased. So that is one of the problem. So to avoid this, we have used CRC, cyclic redundancy check.
भाई कॉल चल रही है कॉल चल रही है
Hello, I think
197
please mute yourself.
197
Hello. All of you, please mute yourself. I am hearing interference. Risha Srivastava, mute yourself. Well, right, right. You can see in my slide. Yes, this is what the block diagram of cyclic redundancy check. So what we do in this sense,
Rubber band.
this is the origin.
It's time to eat the rubber band.
I'm muting all the devices now. You could see the PPT here. This is the block diagram of CRC. This is the original data to be transferred. And what the CRC will do in this sense, it will generate a new new information that is a carrier. It is like a carrier. This is not original information. And this information along with the data will be sent. That means this is called as a extra information. We'll call it as a parity bit. That means along with the data, we add a few more bits and all the informations will be transferred to the receiver side. And in the destination end, what I will do in this end, there is a checker function. What this checker function will do in this sense, it will just separate out the extra information from the original data, because the original data is the one which has been originally transferred, and this is the extra information that has been added along with the original data. So in receiving end, there should be a mechanism to separate out this information from the parity bit. So this is the block diagram of CRC, and you could see here there are 4 types of redundancy we can use in data communication. The third part, you could see the CRC. Okay, this is not a CRC. This is a parity information. It's a vertical parity. That means what you do in the sense, along with the original data, I could add 1. This is extra information. So I have to count how many number of ones in the transmitting it. Here 1, 2, 3, 4 ones are there. So at the destination end also, you could receive only number of ones should be 4. Suppose if the number of 1 is 5, the receiver will identify that some bit has been changed. This is called parity bit. So vertical redundancy chain. And the problem of this parity bit is that, suppose here I have used 4 number of ones here. Suppose if 2 bit has been changed, again in the receiving side it will check it as number of 1 is 6. Again it is number of total number of 1 is 6 is an even. Here, so if you are 4 also even, 6 is also even. So only one bit, if a bit has been changed by only 1 bit, you could able to recover. But if more number of bit has been changed, this mechanism cannot be able to recover. So that is the drawback of this. That is why we go for CRC. So this CRC is again a redundancy checking mechanisms. The primary arithmetic used is binary addition is used. Okay, and so what we'll do in this sense, this is the original data. What we will generate an extra information, and along with this, the data will be transferred. So I'll go to this. You could see this. This is a problem here. The CRC, they will ask about problems. You could see here what the data will be given is, the data will be given as this. Suppose this is the data to be transferred 10 110 11, and they will give you the what is the CRC generated bits. So the problem is given is 1101 is the CRC generated. That means this is extra information that is going to be used with this data. So what you have to do in the sense, you have to use division mechanism here. What you have to do, the initial step is you just use this data here, and you have to add 3 zeros. That means, how do you add 3 zeros? And if the CRC generator is 4 bits, then you have to add n minus 1 bits. That means 4 minus 1 is 3 bits. So 3 zeros you have to add at the end of the data. So this is the divisor, and here 1101 is the CRC generator. So what you have to do in the sense, you have to divide. So just put 1101 here, and you have to use a exclusive OR. You know what is exclusive OR, right? Exclusive OR is nothing but if both the bits are 1, the output is 0. If both the bits are 0, the output is 0. That means if any one of the bit is 1, the output will be 1. Right? That is an exclusive OR. So do here exclusive OR. So 1 1 means 0, 0 1 means 1, 1 0 means 1, 1 1 means 0. So you have to continuously do this. So after this, you just remaining bits, you just use the same remaining bits. Again, use 1 1 0 1, the same thing. Again, do exclusive OR. 1 1 is 0, 0 0 1. Right? Again this remaining bits you put here. Again 1 1 0 1. Again do exclusive OR. 0 0 1 1. Right? Again 1 1 0 1. So this last 3 bits you will get, right? 0 0 1. That you have to take. This is called as a CRC. These 3 bits you have to take, and this previously we added 3 zeros, right, at the end of the information. This 3 0 you have to replace with this 0 0 1. Right? So this is the data code word. So what is my data code word is 10110111, and this 001 I am just adding. That's it. So this is the data code word generated at the sender side. Now this will be transferred across the network, and this information will be received at the receiving side. So in the receiving side, what this will do in the sense, again, this receiving side, this data is here. This is the receiving data. And again, you have to use the same CRC generated data, 1101. So again, the CRC generator will be same both in source and the destination will be the same. So again, I have to use here 1101. Again, do the same mechanism here. Do exclusive OR here. So when you do exclusive OR, the same process you have to repeat. The final stage you will get 0 0 0 0. That means if it is 0 0 0 0 means there is no error. That means data will be accepted. Suppose if any of the bit is changed means you will not get a 0 0 0 0. That means the receiver understands that some bit has been changed and you need to discard the packets. Right? So this is what the CRC mechanism will work. I will just unmute now. If you have any doubts, you can ask your doubts. But one at a time, because if you raise your hands, I can able to unmute yourself. If there is any option to raise your hands,
Yes.
because if I unmute all, everybody will speak. I could not able to hear it properly. Or can you send me a no option is there?
Participants, we have raised hands.
Sorry.
Once we click participants, there is an option downstairs. There is raise hands in the.
Yeah. That means there is no doubt. No doubts.
Okay.
No doubts. Okay, fine. You understand the concepts, CRC?
Yes, sir.
Yes, sir.
So, we'll fourth unit, you will have an analytical both CRC and checksum mechanism. Others and the Hamming code is also there. And I'll again share. So the question will be asked in two ways. One is they will give you the data and they will give you the CRC generated data, right? One more technique is that they will give you the data in terms of polynomials. I'll just again, in terms of polynomials, I could see, I will share the screen here. You can see here, sometimes the data will be given in terms of polynomials. See here, the message is given as x power 3 plus 1, and the CRC generator, it is given as x cube plus x plus 1, right? Now what you have to do here is, this x cube plus 1, you have to take the highest power of the CRC generator. The highest power of the CRC generator is x power 3. So you have to multiply with this, with the original data. So that means x cube plus 1 is the original data, multiplied with the highest power of CRC is x cube. So if you multiply, you could get x power 6 plus x power 2. So this is the data word, right? And what you have to do in the sense, you have to use this data word x cube plus x power 6 plus x cube, and the CRC generator is x cube plus x plus 1, right? So here x power 3 is there, you put here in the device x power 3. So x power 3 into x power 3, x power 6, plus x power 4 will come here, plus x power 3. Am I correct? So if you subtract it, you will give it x power 4. This x cube and x cube will be subtracted. You will get only x power 4. Then again, this x power 4, if you add plus x, you will get x power 4 plus x square plus x. So if you subtract, means you will get x square plus x. This is a reminder. So usually what you will do, this data x cube plus x power 6 plus x cube, plus we will add this x square plus x, because in the earlier problem also we have discussed the same thing, right? To get a reminder, this reminder will be appended with the original data. That is what again we are doing here also. So this is the data code word at the sending it, right? So sometimes they will be giving you in terms of polynomials. Again, okay. So on the destination end, what you do, you use the same here, x power this data. The CRC generator is x cube plus x plus 1. Again, make use of the same thing. So x power 6, x power 4 plus x cube. Again, if you subtract, if you get 0. So if you are getting 0, means there is no error. That means you have to accept the data. So this is in terms of polynomials. The polynomial also, you can convert this polynomial in terms of binary streams also. This is the way you have to convert. See, if you want to make use of this kind of things, you can also do. Otherwise, if you want to follow the first method, you can do this also. So this is the data x power, right? So x power 0 is 1 here. There is no x power 1, x power 2. Only x power 3 is there. So that means what is a binary bit? 1, 0, 0, 1. That is the data. And CRC generated is given as x cube plus x plus 1, right? So what is the data here? X power 0 is 1. So 1, x is 1. There is no x power 2. So 0, 1. So 1, 0, 1, 1. Right? Use the same thing here. Yes. So I use here 1, 0, 0, 1. So I used 3 zeros here at the end, and the same thing I'm doing. So use exclusive OR here. The same thing. This is, so you have to follow the same approach what we have followed in the first time, right? Okay, that is all my side. If you have any doubts, you can ask. Otherwise, we'll wind up our class. Any doubts? Anybody wants to ask few questions? Hello? Hello?
We will refer and ask you in the next class.
Okay, fine, fine.
Thank you, sir.
Thank you, Ra. Thank you. We'll close our meeting. Thank you.
Thank you, sir.
Thank you for joining.
Sir.
Yeah.
Thank you, sir.
Thank you, ma. Thank you.
Thank you, sir.
Thank you. Hello?
Can we leave the meeting, sir?
Yeah, yeah, Ra. Okay, fine. You can leave.